Okay, so yes, exactly. Differentiation is the act of finding a derivative. So if we have differentiation rules, these are going to be rules that tell us how to find a derivative. So we're going to start off by thinking about a constant rule. And so I'll remind you we have two different notations for a derivative. I could have k with a prime, and that means take the derivative of k. Or I could have d dx k. Both of these things, both of these two different notations mean take the derivative of k, where k is just some constant. So let's take a look then at what the graph of y equals k would look like. We looked at this yesterday in class. If I have y equals k, what shape, what kind of line is that? Does it look like this? Does it look like this? Is it vertical? Is it horizontal? Does it have some kind of slope? What does y equals k look like? Again, this is something that you have in your notes yesterday in our little like mini review of slopes that we did. So if you need a look, you can. There you go, Gwen. Thank you. Horizontal. This is a horizontal line. So y is equal to k would look, oops, I'll do this in red. Y is equal to k would look something like that, where that value right there is k. And what is the slope of a horizontal line? 0. So then what is the derivative of a constant? Also 0. So if we're saying what is the derivative of that constant? Well, the slope of that line is just 0. So the derivative of a constant is just 0. So then we're going to have a linear function rule. And a linear function is one that makes a line. So that's like y is equal to mx plus b. So if I have the derivative of mx plus b, my line, or d dx mx plus b, either of these are telling me take the derivative. Again, we can kind of think of the answer to these things in terms of a slope. If I have y is equal to mx plus b, what's the slope? M, you got it. That M is the thing that gives me the slope. Oh, actually you guys use A here, don't you? I guess it doesn't matter. So then what's the derivative of y equals mx plus b? It's also going to just be that m. You got it. Or a if we're using a instead of m. So the derivative of a line is just the slope of that line. Okay, let's just do a couple examples where we see this with actual numbers. If I were to ask you for the derivative of 5, what's the answer? 0. It's just a constant. If I were to ask you for the derivative of pi, what's the answer? Also 0. Pi is just a constant. If I were to ask you for the derivative, and this one might be new to you guys, of e, what's the answer? If I go to my calculator and I just type in e, this is what it tells me. You guys see what it tells me? Is that just a number? Yep, and what's the derivative of just a number? 0. So this is 0. So in the same way that pi is a letter representing a number, e is a letter representing a number as well. So I'm sure you guys have seen that. So we'll just remember e is approximately equal to 2.71828. It is just a constant. So with that in mind, I'm going to ask you one more that might seem a little bit weird. What is the derivative of ln 8? Maybe you don't remember logs at all. Maybe you don't remember what ln means. It doesn't matter. Do you have an ln button in your calculator? You got it, Mikhail. It's going to be 0. Ln 8 is just a number. You don't have to know how to calculate that number. It doesn't matter. Your calculator will do it for you. I press ln 8 and look, it's like 2.079441542. Whatever, I don't care. It's just a number, therefore its derivative is 0. Does that make sense? What about this? D dx, so again, that's saying differentiate, take the derivative of 2x plus 9. You got it, Mikhail. 2. This is a line that has a slope of 2. What about this? You got it. This is just another line whose slope is pi. Notice it doesn't matter which notation I use. I use d dx, but I can also use prime, and you'll see them interchangeably. So what if I have ex plus ln 7 prime? What's that going to give me? It's just e. You got it. That's a line whose slope is e. Not h7 ln 7, so that's natural log. And right now, I'm just kind of throwing those in there because those are numbers that your calculator can calculate. We are going to talk together more about the natural log later, because it is quite important. But for now, all we're going to be doing with it is derivatives. So we don't really need to know, sounds terrible, what it means at this point. I promise we will start reviewing it a little bit later. Today, we're just going to kind of see it in this format. Like recognize, hey, that's a number, not a big deal. Okay, so are there any questions about these examples that we just did and how we were able to figure them out by thinking of the derivative as slope? So now I'm going to tell you a few derivatives. It's going to be a little bit harder from here on out to really come up with derivatives based on slope. So I'm going to tell you a few, and let's see if we can come up with a pattern together. If I have d dx of x, what does that equal? That one we just did. Based on what we just talked about in terms of lines and slope, oops, what's the derivative of x? Not 0. Oh, there we go. 1. Exactly. 1. This is a line of slope 1. I'm thinking of this as like y equals ax plus b. In this case, a is equal to 1, b is equal to 0. This is a line of slope 1. The derivative of x is just 1. You guys with me still? Okay, so now I'm going to give you another one. This one you won't be able to do based on what we just did. The derivative of x squared, it turns out is 2x. The derivative of x cubed, it turns out is 3x squared. The derivative of x to the fourth, it turns out is 4x cubed. So, yeah. Good job, guys. Derivative of x was 1. Derivative of x squared was 2x. Derivative of x cubed was 3x squared. Derivative of x to the fourth was 4x cubed. So what's the derivative of x to the fifth? Do you guys think that the people that have answered so far are correct? Good. I do too. That is the answer. 5x to the fourth. So in other words, by looking at those original derivatives, we were easily able to figure this new one out. And this brings us to our next rule, which is actually one of the most important rules that we're going to learn for derivatives, and it's called the power rule. And the power rule tells me what to do if I have x to the power of some number. So based on all those derivatives we just calculated up there, you guys were able to find 5x to the fourth. What do you think the derivative of x to the power of n is? You got it, Jenny. It will be, we bring the power down, x, and then we subtract 1. n x to the n minus 1. So our other way of writing this, our other notation, d dx x to the power of n, is n x to the n minus 1. Okay, so let's just do a couple examples of this, and then we're going to remind ourselves of a whole bunch of algebra rules that are going to allow us to use the power rule. So first of all, I want us just to remind you, we have 3 rules today that we've seen so far. The constant rule, our linear function rule, and the power rule. And the power rule, if we think about it, actually extends to the linear function rule and the constant rule. So let's do a couple examples here. What will the derivative of x to the 1000 be? You got it. 1000 x to the 999. B. The dx, I'm sorry, I want that to be a t. I can also change my variable, so I could have d dt t to the 7th. So here this is the same thing, it's just in terms of t, and I want you to notice that then that thing on the bottom becomes d dt. So it's like the change in t as opposed to the change in x. And what's that going to give me? 7t to the 6. And let's just do one more. X to the pi. What's x to the pi? What's the derivative of that going to be? You got it, Ning. Pi x to the pi minus 1. I just bring the pi down. Then my x, I subtract 1 from the power. So it's just pi x to the pi minus 1. And I'm going to do the same thing with an e. What's that going to give me? Perfect. E x to the e minus 1. And then we can also do that with those lns that we saw up there. So the natural log. What if I had a power of ln 5? Same thing, I bring the ln 5 down, and then my x is to the power of ln 5, and I'm subtracting 1 from that. So we don't really even have to think about it, nothing's changing, we just bring the power down and subtract 1. Who remembers what ln means? It's on the natural log. What's the base of the natural log? You got it, Kenzo, e. So it's a log base e. So again, today that's not all that important, but it will become important eventually. Okay, so this is our power rule, and our power rule is incredibly powerful. Can you imagine trying to plug x to the 1000 into the limit definition of the derivative and doing that? You would have to expand x plus h to the power of 1000. You would have to expand this, which means you'd have to multiply x plus h by itself 1000 times. Does that seem like a fun thing to do with the limit definition of the derivative? Let me tell you that I will never do that ever. That seems like a really horrible thing. And I love math, and I love algebra, and I don't want to do that. So anyway, this power rule is really powerful because it stops us from having to do things like expand x plus h to the 1000, which is just like gross. Okay, so that's our power rule. We have a couple more derivative laws that we're going to see today that is going to allow us to combine this power rule with the other rules that we've seen. So we have something called the constant multiple rule. And the constant multiple rule tells me that If I have a constant out front, that's not going to change my derivative. In other words, I can stick that constant on the outside or have it on the inside. And we'll just see one quick example of this before we look at the next rule. So what this is saying is that if I have the derivative of 7x cubed, that 7 is not important when I'm thinking about how to do the derivative. So we don't have to write this step, and in fact, in the future, I will never write it again. But in other words, I can say I can bring that 7 to the outside and just do the derivative of x cubed. What's the derivative of x cubed? Based on the power rule that we just learned. 3x squared. So notice the 7 didn't go into my calculation of the derivative. I calculated the derivative and then I'm multiplying by 7. So that's 21x squared. Or I could also do ln 6x prime. Again, that ln 6 right there is just a constant. I'm sorry, I want that to be an x to the 6, my bad. So this is saying I can bring that ln 6 to the outside and then just have the derivative of x to the 6. What is the derivative of x to the 6? 6x to the 5th. Okay, so the reason I wanted to add this one here is because you need to be careful. A lot of people think that you can multiply those 6's together. But ln 6 is a number in and of itself. So a better way to write this would be 6 ln 6 times x to the 5th. So just make a note to yourself to be careful. Ln 6 times 6 does not equal to ln of 36. In other words, I can't multiply those two 6's together. Does that make sense? Ln 6 times 6. Yeah, so it'd be 10.75, but 0.5, blah, blah, blah. I'm going to ask you to not give me a decimal, though. We want exact answers. And with that decimal, it's irrational, which means that the decimal goes on and on and on forever. So we don't want to give the decimal. We want to leave it in that form 6 ln 6 so that our answer is exact. Okay. So the next rule that we're going to see, and really the last rule today before we just combine all of these things and do some crazy algebra, is the sum and difference rule. And the sum difference rule tells me that if I have a sum or a difference being subtraction, a sum being addition, then I can distribute the derivative inside. So an example of this, just so to make sure that we understand what this means, is that if I have the derivative of, for example, 7x squared plus 3x cubed plus 5, then I can just do each of those derivatives separately. So what do you guys think the derivative of 7x squared is? (14x). Plus, what's the derivative of 3x cubed? (9x squared). Plus, what's the derivative of 5? 0. So I don't need to write that. I'm going to just write it in red at the end because it's really not that important. So in other words, I just did each of them separately, and notice that in this case, I just immediately applied that constant multiple rule without even thinking about it. I didn't do like, so this is 7 times 2x. I don't have to separate it out like that every single time. I just immediately went straight to 14x. In the same way, I didn't do 3 times 3x squared. I just immediately went to 9x squared, and that's fine. So you don't have to write out these rules every single time. So we'll do one more example of this. So this is saying that I can separate this. I can do first the derivative of pi x to the e, and then the derivative of ex. So what's my final answer going to be here? You guys can say it in words or tell me in the chat. What will my final answer be for this one? Yeah, so first I'm going to bring that e down. So I'll have pi e x to the e minus 1. So that's going to be the first part. Good job, Nick. And then what about the second part? So I just brought the e down, and then I'm subtracting 1 from the e. What is the derivative of ex? You got it, Emil, that's just e. So plus e, and that's my final answer there. All right, these are our rules. Are there any questions about these rules or about any of the derivatives that we have just taken? Okay, so at this point, what this is telling us is if a function is not of this form exactly, then we can't do the derivative yet. Later, we'll see a couple more rules that are a little more complicated, but right now, this is kind of it. Like, it has to be x to a power times a constant for me to be able to do it. So a lot of times it doesn't show up this way, and we're going to have to use some algebra rules to simplify things in order to use the power rule. So we'll have this new little section called Using Algebra to Simplify to the Power Rule. And so we've actually kind of reminded ourselves of these algebra rules already in this class, but we'll still, I'm still going to show them to you again, just so that they're fresh in your minds. How can I rewrite the nth root of x to the power of n? X to what power? No. Does anyone else have any ideas? So I'm not asking us to do the derivative right now. I'm asking us to just rewrite the thing. So if I want to rewrite this thing, I actually do the inside divided by the outside. So n divided by n. So this is a rule that you guys need to get comfortable with. And we'll see it in action in just a second. Another rule that you guys need to get comfortable with that we did remind ourselves of for sure is x to the power of a over x to the power of b. How can I rewrite that as x to just some power? This one hopefully you guys are a little more familiar with. You got it. This will be x to the power of a minus b, which means that if I just have a constant on top, which I'm going to write as a k, and x to the a on the bottom, that can be k x to what power? Negative a. So it's not exactly, well, it's not 1 minus a, it's just negative a, right? Because there's nothing on top. So that means when I bring it up, I just change the sign to make that sign negative. Okay, so these are the 3 important algebra rules that we're going to be using to simplify. And we're going to find the following derivatives. So we're going to do a bunch of problems where we have to use these algebra rules. Differentiate the following functions. Actually, let's do it this way. F of x is equal to the square root of x. I want to differentiate that, which means I want to take the derivative. What we have seen, and I'm going to remind us of it up here, hopefully it's like already in your heads, is that if I have x to a power, then I can just pull the power down and subtract 1 from the exponent. How can I rewrite this square root as x to a power? You got it. So that's x to the 1 over 2, which means that the derivative, f prime of x, I'm going to get by taking that 1/2 down and subtracting 1. So it will be 1/2 x to the negative 1/2. Now I can make this a little bit more complicated by throwing a constant out front and having like an 8th root of x to the power of 9. Oops, I forgot my f of x. So again, I'm going to need to use that first algebra rule to rewrite this. How can I rewrite this? How can I use that first rule to, you got it. It's going to be x to the 9 over 8. Notice that 6 is not part of the radical. It's not part of that root. So that 6 just stays out front, and the x becomes to the power of 9 over 8. You guys see that? So now when I do my derivative, I'm going to apply the constant multiple rule. So the constant multiple rule says that 6 is not important, so I can just write down the constant, and then I'm bringing that 9 over 8 down to the front, and I'm subtracting 1. So I'll have 6 times 9 over 8, x to the 9 over 8 minus 1, so that's 1 over 8. Okay. So far, so good. Any questions? Actually, we'll do this. So that 5 over 4, I have 5x to the 6 over 4x to the 8. That 5 over 4 doesn't matter, so I'm going to stick it out front. And I need to just have x to a power. What will be my new power of x? X to the negative 2. You got it, 6 minus 8. Now this is important. I want to be clear that we have to do this. I cannot just do 6x to the 5th on top and 8x to the 7th on the bottom. I can't just do the derivative of the top over the derivative of the bottom. I have to simplify this in order to use the power rule. Which means that now f prime of x is that 5 over 4, that's my constant out front. I bring the negative 2 down, x to the new power, I subtract 1. So I'm going to have a new power of negative 3. Okay, I want to do one more before I add another algebra rule. So I have 6 over the 4th root of x to the 7th. I'm going to write this as 6 over, what will the power of x be in the denominator? So using that first rule, what's the power of x going to be? 7 over 4, you got it. So x to the 7 over 4. So based on what we just said, can I take the derivative from here, or do I need to do something else? Let's go for a vote. Tell me in the chat. Take from here, do something else. You can tell me privately. We'll have a third option. Take from here, do something else. I have no clue. Got 2 answers. There are 19 of you.
Miss, can you just repeat the question?
So the question is, do we want to take the derivative as it is right here, or do I need to simplify more in order to take the derivative? All right. All right, so we're getting a lot of good answers here. So the issue is we have the same problem that I had in the previous one, that x is in the denominator. My power rule doesn't have x in the denominator, so I have to move it up. I can't just take the derivative when it's in the denominator. So I must move it up in order to apply the power rule. Which means, so I think a couple of you said it, that means we're going to end up with 6x to the negative 7 over 4. So f prime of x is 6. I'm bringing the negative 7 over 4 down. X to the negative 7 over 4 minus 1. So again, I bring that negative 7 over 4 down, and I subtract 1. To get my final answer. Okay, now hopefully you guys left space. I'm sorry, I should have mentioned that you should. I'm gonna add one more algebra rule. We've used all 3 of those. We have one left that we need to see. Oops. And that is, what if I have x to the a times x to the b? How can I rewrite that as just 1x to a power? You got it, Jenny. X to the power of a plus b. We're going to do one last problem here before we start finding some equations of tangent lines. So we're gonna apply every single rule that we have learned now. We're gonna start off, you guys ready? By recognizing that I have 4 things here, which means I have 4 different derivatives that I'm gonna have to take. But my first thing that I need to do is simplify. So I'm gonna start off by simplifying. How can I rewrite x times the square root of x? That's the same thing as x times x to the 1/2. So 1, 2, 3, or 4, which one of my algebra rules am I gonna use? Well, I used the first one to get that, but now how can I get from x times x to the 1/2 to just 1x to a power? If I have x to the power of 1 times x to the power of 1/2, I'm going to use the 4th rule. You got it, guys. And what will my new power of x be when I apply that 4th rule? 3/2. Are there any questions about how I just got that x to the power of 3/2? Good. Plus, so that x to the power of 3/2, first I said x times the square root of x is the same thing as x times x to the 1/2. So that then becomes x to the 1 plus 1/2, and I'm applying that 4th algebra rule that we have right there. So I'm just adding my exponents. Does that make sense? Okay, what's my next term gonna look like? You got it, I'm gonna have a 2/3, and then it's just gonna be x plus, what about my next term? Five x to the 7/3, you got it. And then minus, what about my last term? So that 6 is a constant. So I'm like gonna move that 6 to the front, and then I'm just gonna have x to a power. So like the 6 is like the k from the rule. So the question is, what's the power of x? What power should I put up there with my x? It's gonna be a -1. Good job, Dean. Good job, Nick. X to the -1, right? So when there is no number down there, that's like I have x to the power of 1. There's a 1 hiding. Have I taken the derivative yet? No, I haven't. Those are just algebra rules. I've simplified it so that now I can take the derivative. So then I'll have f prime of x, and now I'm just gonna apply my power rule to each one. So I'll have 3/2, x to the 1/2. I'm bringing the 3/2 down, and I'm subtracting 1. What's the derivative of 2/3 x? It's the second rule we saw today. You got it, Claudia. It's just 2/3. So plus 2/3 plus 5. I'm bringing that 7/3 down. So I'll have 5 times 7/3, and then I'm subtracting 1 to get 4/3. And then same thing here, I'm gonna bring the -1 down, and I'm gonna subtract 1. So that's -6 times -1, x to the -2. And voila, that's my answer. Are there any questions about this? Okay, so we're gonna add on to this a little bit. We're still just gonna be finding derivatives, but we're gonna really go back and associate it with slope now. So let's go back and associating with slope. And there are a few different types of questions I can ask here. So we want to find the equation of the tangent line to this function at the x value 4. So in the videos that you guys watched with the limit definition, you learned the steps for finding a tangent line. Do you guys remember what the first step was? What is the first thing you need to do in order to find the equation of a tangent line? So we don't plug in 4 first. We are going to have to simplify in this particular case. Yes, Jenny, we find the derivative of the function in order to find the slope. So I'm just going to remind you guys of that here. Find derivative to find slope. And so up till now, in order to find the derivative, you guys had to use that limit definition of the derivative. But now I have this new way of doing it where I can just use the power rule. I can use those rules that I saw today. So Mikael said the first thing we're going to have to do is simplify, and we don't have to use the limit definition anymore. Okay, so here I have that y is equal to the square root of x, which I know is x to the power of 1/2, times, what's the cubed root of x? What power is x to there? X to what power? X to the power of 1/3, exactly. And if I want, I can't just do 1 times the other. I need to write this as x to just 1 power. What's my new power going to be? You got it, Mikael, 5/6. So this is going to be x to the 1/2 plus 1/3. So we must simplify to apply the power rule. Which means that y prime comes from bringing the 5/6 down and subtracting 1. Are there any questions so far? Good. I just realized that it says x equals 4. It is supposed to say x equals 64. I'm sorry about that. That's supposed to be a 64 there. I forgot to write the 6. Okay, so this is our derivative. So then we actually need to use that derivative to find the slope. And how do I use the derivative to find the slope? How am I going to find the slope? We're going to plug in 64, exactly. So here I'm saying y prime of 64, and so I'll have 5 over 6 times 64 to the negative 1 over 6. You can plug that into your calculators to see that the 6th root of 64 is 2, so that's a 1/2, and this gives me a 5 over 12. I want you guys to take a second, you got it, Marino. So I want you guys to take a second to make sure that you're capable of plugging that into your calculators. If you don't, we can have a little calculator tutorial where I can show you how to do it if you don't know how. Does anyone need help plugging that into your calculator? Take a second and try. Okay, so here you have your calculator. It probably looks something like this. It might be a nicer version. Mine's a little bit old at this point. But I'm taking 64 and I want to put it to the power of 1/6 or negative 1/6. So there's a y to the x button that you see right there. Do you guys see the y to the x button? So mine's right there. You should have a y to the power of x. Mine's on the very left side of my calculator, kind of like 2 above the 7. So I'm going to press that button, and then in parentheses, I'm going to do the negative 1 divided by 6. So if you guys look at my calculator screen, you can see how I put in parentheses negative 1 divided by 6. And that gave me a 0.5 right there. And if I press this button right here, this is my fraction button. Have you guys gotten used to the fraction button yet? So it's this a/b over c. If you press the fraction button, it will turn it into a fraction for you. So I have 64 to the power of negative 1 over 6. That gives me the 0.5. Then I press the fraction button, and hopefully you know that 0.5 is a half, but it turns it into that 1/2 for you. So another thing that's important is now I'm going to multiply that 1/2 by 5/6. You want your answer to be a fraction. So I'm going to do times, and I'm going to open some parentheses, and instead of doing 5 divided by 6, I want to use my fraction button. So I'm going to press the fraction button, and then I press 6. And that gives me times 5 over 6. You'll notice it has, like, I've heard people call it an R. It's just like a little line between the 5 and 6. It gave me a decimal, so then I press the fraction button again, and it turns it into a 5/12. Do you guys all see the fraction button on your calculators? It's the a, b over c. Mine is like kind of right above the 8. It says error 1. Ismain, are you putting the negative 1/6 in parentheses? And also, do you have the right calculator? Yeah. So are you putting the negative 1/6 in parentheses? Make sure that that power is in parentheses. Oh, another thing is when you're doing -1, make sure you use the plus minus button down here instead of the negative button. So you want to do, you'll press 1 and then you'll press the plus minus button. That makes it a -1. Did that help? You mean for the fraction button? You had 0.5 and you pressed the fraction button and it gave you an error? Oh, if it depends on, like, if you have the 0.5 in, if you type 0.5 in yourself and then press the fraction button, it's going to give you an error. But if that 0.5 occurred because of calculations you previously did, then it will turn it into a decimal. If you want to turn 0.5 into a fraction, you can do 0.5 over 1 using the fraction button, and then it'll turn you into the fraction for you. Okay, so are there any other questions about the calculator? Were you guys all able to get the 5/12 for me? Good. So then what's my next step? Once I have the slope, we move on to the next step, which is what? Anyone remember? The point. We just need 1 point. So I need the y value of the point. And I find that by plugging into the original function. So I'm rewriting out these steps just because I did them in a video, but like you should technically already have these steps as well. Now we're just seeing it without the limit definition. So in other words, I want to know what is y of 64. And so that's the square root of 64 times the cubed root of 64. I don't know why I wrote 3. Which is 2 times 4, which is 8. Wait, is the cubed root of 64? No, I'm sorry, the cubed root of 64 is 8, my bad. No, it is 4, what am I saying? Yes, you got it. So that gives us a 32. Yeah, I'm sorry, I for some reason decided that the square root of 64 was 2, which makes perfect sense, right? So that gives me a 32, which means that my point is 432. So that's my point. You guys all know how to do the cubed root on your calculator. Anyone need help with the cubed root on the calculator? Okay, so our third step now is to find the line. Plug in the point and the slope. Wait, you need help with the cubed root, Gwen? Is that what you're saying? Okay, so what you're gonna do is the root that you want is the cubed root. So you're gonna press 3, and then you're gonna press the second, the orange button that's up here, and then you're gonna press the y to the x button. So you'll see it has like x root. And you should get something that looks like that, where you have 3 with the root, and then you stick the number inside the root. So like mine's gonna look like that. Did that help, Gwen? Good. So Nick, I'm gonna finish the question and then I'll go back and answer that again, okay? So that's one of the things I talked about in the video, but we'll look at a graph again as soon as we're done with the question. So first, next thing I wanna do is to plug in to find b and write the line. So I know that my line here is y is equal to 5 over 12x plus b. My slope goes right there. And then I'm plugging that y, oh my God. Thank you. That's why it should be 64. I have just decided that it's a 4 instead of a 64 today. I even did the square root of 4 instead of the square root of 64. I'm sorry, guys. Does that make more sense, Nick? My brain is just like, does not want that 6 to be there. Okay, so that's my slope. Now I'm plugging in my point, and I'm doing that to find b. So I have 32, that's my y value, is 5 over 12 times 64 plus b. So that's 32, and I'm just going to show this in the calculator so that you guys can get comfortable with it. 5 over 12, I'm not going to use division, I'm going to use the fraction button. So I have 5 fraction button 12 times 64. Okay, guys, this is important. It gives me a fraction that looks like this. Do you guys see the fraction I'm showing you? This is an improper fraction. So I'm going to press second, and then I press the fraction button again. And it takes that improper fraction and turns it into a proper fraction. So now it's just 80 over 3. And it's really important for you guys to be able to use that because I don't accept improper fractions and your answer should be not decimals but fractions. So you get that improper fraction that looks like that. You guys see it? And then you press second and you press the fraction button again to get an 80 over 3. So now I have 80 over 3 plus b, which means that b is equal to 32 minus 80 over 3. So I'm going to do this again just to show you. So I'm going to do 32 minus, when I do 80 over 3, I don't use the division sign, I use the fraction button, 80 over 3. I get an improper fraction. So what do? I press second, and then I press the fraction button again. And now I have a 16/3. So y is equal to 5/12x plus 16/3. And that's the final answer. And now we are officially done with class today. If you guys need help with the fraction button, or you need to figure out more information on how to use your calculators, let me know. We can have like a little another tutorial in class. I'm also happy to help you in my office hours.